Hello everybody, today we will be studying what binary search is. So let's get started. See, the thing about binary search is that it is used to find a specific element inside an array. So the two things which you should remember is that binary search is always applicable only on an array which is sorted. Now a sorted array means the elements are arranged either in increasing or decreasing order. So the first thing you have to remember is binary search is applicable only for sorted arrays. So let's write only applicable for sorted arrays, increasing or decreasing. And the other thing which you have to remember is, if inside the question if they say solve this question using big O of log n complexity, then you should always use this thing, binary search you have to use. So if you see these two things, sorted arrays and big O of log n, this means binary search is for sure going to be used in the question. So here you can see I have taken an array which is of size 11. So the first thing we have to remember is array is nothing but it's a collection of elements, and these elements could be numbers, it could be alphabets, it could be anything. So here in this example I have taken an example of numbers, and here all these elements which you see are arranged in increasing order, so it's a sorted array. And also remember one thing, arrays are numbered, they are called as indexed. So the first element always starts with the index of 0, and then it goes 1 2 3 4 5 6 7 8 9 10 11. Okay, so with the help of binary search we find a specific element. So for example, if my target, let's call it as target, or even you can call it as key. So suppose if I want to search an element called as 15, so I want to find 15. So basically I just want to find the position, which is nothing but the index value where the 15 element is present in the array. So how do I do it? In binary search we always divide the array into half. So first let's find the middle of this entire array. So this is the start and this is the end, and we want to find the middle. So mid is equal to start plus end by 2, and here I'm going to use the index values. So 0 plus 11 by 2, you get the answer as 5.5, but here we round off the value to the left part, so it becomes basically 5. So the fifth index is the mid. So the fifth index is the middle element, so which is this one. So this is the mid. Let me make this a bit clean. Yeah, and this blue one is our target element which we want to find, like we want to find the sixth position. So how do we do this? So the algorithm for binary search is that first, so this is basically the step 1, which is to find the mid of the element, mid of the array. Then after that we the step 2 is of the comparisons, and we basically do 3 comparisons. So the first comparison which we do is if array of mid is equal to the target. So if that is the case, then we just, so this is the first comparison which we do. The second comparison we do is if array of mid is less than the target, and the third possible condition could be is if array of mid is greater than the target. So if this is the first so in the first condition is basically the middlemost element is exactly our target. So here our target is the 15 and the middlemost element is 11, which is not our case. They aren't equal. So but if that is the case, if hypothetically that happens, then I would just return mid. The mid is basically the position, and if mid is less than the target, so here we are seeing yes, our mid is 11 and our target is 15 and 11 is less than 15. So what we do is we write a thing called as start is equal to mid plus 1. The moment we found out that our mid is less than the target, that is 11 is less than 15, I just change the position of start. So here you see the position of start is at 2, but here I am changing the position of start to start is equal to mid plus 1. So I just basically move the position of start to mid plus 1, which is nothing but 5th index plus 1, which is the 6th position. So my start then goes over here, and this is the new start position. So what happens is that I just eliminated one entire half of the array. I just eliminated one entire half of the portion of the entire array, so that way I am saving time and it is much faster. The third condition, which is if array of mid is greater than the target. So for in this case, let's just for example just see if our target, I'm just changing the target for now, in this case if array of mid is greater than the target, so basically let's say my target is 8. Suppose if this is my target, and definitely this is the case where array of mid, which is nothing but what it is 11 is greater than the target, which is 8. So what I do is I just write end is equal to mid minus 1. So what does this mean is this entire part just gets eliminated and my this end value goes over here, so it changes its value. So my right half just got entirely kicked out and this becomes my new end. That's it. This was the the code of this thing, binary search. And what I would just say is, if you are eliminating the right half, so just remember in this way is if you want to kick out the right half of the array, just remember it is start is equal to mid plus 1, and if you want to remove the left half of the entire array, it's end is equal to mid minus 1. That's it. So now let's go on to LeetCode and let's solve this question in C++ language. So this is how the LeetCode question looks, which is binary search. You are given an array of integers nums which are sorted in ascending order. So basically you are just given an array, and these the elements inside this array, I mean the numbers inside the array are arranged in increasing order, and the target is 9, and we just have to find the position of 9, which is if you see, which is 0, 1, 2, 3 and 4. It's at the 4th position. So 9 exists in num and it's at the 4th position, the 4th index. And the other thing which you have told is, if the number doesn't exist, return -1. And the other also thing which they have told is, write an algorithm which can be done in big O of log n. Now why this question can be done even in much simpler way, which is by using this question can be done even by using an for loop and to check every single element. But if we do that way, we are just checking for every single element and we are checking it for n times. If the array of the size, if the size of the array is n, then we are checking it for n times. Each and every element is being compared and it is checked if it is equal to the target or not. So in that case, the time complexity becomes big O of n, which is not great, which is takes more time. Big O of log n is smaller. So what I told was, as I told, if you see sorted written in your question, if you see sorted written in your question, and if you see big O of log n, then you're going to use this thing, binary search. So the three things which we use, first is start. So I am giving start as 0, then int end is equal to nums dot size -1. Now basically just don't get confused by this vector, nums, all such things. Just remember, for now, just for sake of simplicity, imagine vector as is just an array and the name of the array is nums, and to find the size of the array we just use dot size, name of the array dot size, you get the size of the array. So end is equal to nums dot size minus 1. So now let's do one more thing. While start is less than equal to end, int mid is equal to start plus end by 2, and then what we do, we check for 3 conditions. The first condition is if mid is equal to the target, if mid is less than the target, and if mid is greater than the target. So this one we write it as if nums mid equal to target, then I just return mid. Else if nums dot mid is less than the target, then I write start is equal to mid plus 1, and finally else is final condition is I can just write end is equal to mid minus 1, or you can just also write the condition which is nothing but nums mid is greater than the target. So that's how you can do this. So these are the 3 conditions, and if it doesn't include, if the target doesn't even exist, then I just return as minus 1, and this is how my code looks entirely. And let's just run and see how does it work. There is a compile error, else turn mid and nums mid is greater than the target. Okay, I didn't put a error. Now if we run again, if I remove this part, because we shouldn't be writing the you can just for the sake of simplicity just don't write that part, because else is just the final condition, if else if and else, and both of our text cases are passed. So in this is the input and the target is 9, so it exists at the 4th position, and the case 2 is they have given us target as 2, but 2 doesn't exist over here, so the output is minus 1. And let's just submit this code and hopefully it gets submitted. Yes, it is submitted, and if we analyze the complexity, the time complexity is big O of log n, which is standard. Like every question which you solve using binary search will always have a time complexity of big O of log n. So thank you so much for watching this video. Until next time, goodbye. This was my first video in the world of coding, so yeah, okay, thank you so much, bye.